Hello, my name is Mason Hedge, and today I'm going to be talking about the effect that certain drinks have on your voice. So, why am I doing this? Well, that is a great question. I'm heavily involved with music in my life. Band, chorus, musical theater, and even more. I've done a lot of music activities through this school. I've always been told not to drink milk or milk products before a show, whether it be before a musical theater performance or before a choir performance. So I've always wondered something about this. So how does the temperature of milk affect your singing voice, and is this even really true in the first place? So the first question that I'm going to be asking is, how does the temperature of milk affect your singing voice? And so to do this, I've done a couple of things. I pour 1/2 cup of skim milk into a regular measuring cup. I then used a digital thermometer to record its temperature. And I recorded the temperature in 4 different ways to get 4 different temperatures. I drank it straight from the fridge at 46 degrees Fahrenheit. I then I let it sit at room temperature at 57 degrees Fahrenheit, put it in the freezer at 34 degrees Fahrenheit, or put it in the microwave at 70 degrees Fahrenheit. Now, I didn't do all of this at once. What I first did is drank it straight from the fridge at 46 degrees Fahrenheit. And then after I drank that 1/2 cup of milk and got its temperature, I then immediately after drinking, I record how high and low my voice can go. And this is known as your vocal range. So I use a keyboard to know what notes I am singing, and then I use a tuner on my phone to record my data in hertz. Now, when you're using a tuner, you'll notice that there are numeric, notes on the actual tuner, which ranges from A, B, C, D, E, F, G, and then there's a whole bunch of flats and sharps in there. We're not going to be worrying about those notes. We're going to be worrying about the numerical data behind the note, which is just the frequency behind the note, which is in hertz. So you'll get a numerical value out of that. So if you're still confused on how I'm actually getting my notes, I've actually made this slide so that you can actually see how I'm getting the notes. So here's me going up on the keyboard to get my highest note. So obviously you can see that I am a true man in the inside, but that's how I'm doing it. I start at a certain note and then I just go my way up the keyboard until I can reach the highest note, and then I go to my tuner and figure out the numerical value in hertz. And if you wanted to see me going down, this is it. As you could probably see, I'm a more higher ranged person than a lower range person, which means I can hit high notes easier than low notes. And that does kind of come into a certain effect later into this presentation. So what you can already notice at the bottom is that this wasn't actually used for milk, which is the first part of my experiment. This was actually used for water, which is later in the presentation. I actually experimented with water next because it does help your voice, and that's what these recordings came from. So here's some data that I have for you guys. So you can see the temperature of the milk. Obviously, something that I should probably mention is that I waited 1 to 2 hours between each time I drank milk, just so that you can get the milk out of your system. So be like you're just drinking brand new milk and coating your voice yet again. So what I first did is did the 46 degrees Fahrenheit one, got my data for that, and then waited 1 to 2 hours before going on to the next temperature of milk. That's how I'm doing all of this. And so you can see the different temperatures of milk right here, the highest note hit in hertz and the lowest note hit in hertz. And then all of that I put onto a graph right here, and you can already see something on the graph. You can kind of see that as the temperature is increasing, the actual note value is the highest note value and the lowest note value are decreasing. So you can see it's kind of going downwards. And that basically means that your vocal range is decreasing. And that's our first conclusion here. So milk isn't as detrimental to your voice as I thought it was. There is definitely an effect here, but it's not really, really, really big. It's not like you're going up and down octaves. It's like you're not hitting one or two notes as temperature increases. It didn't do as much as I thought it would, but it was definitely not fun to do at all. I did not like my voice singing on milk, but there is still an effect. So as the temperature of milk increases, your vocal range is going to decrease. So what do I do now? To see how badly milk affected my voice, I now wanted to test with water. So water is said to help your singing voice, unlike milk, which actually destroys it. So the next question I'm asking is, what is the effect of milk on your voice compared to the effect of water on your voice? So I'm comparing milk and water just to see like how good is water and how bad is milk. So the next setup is I'm practically doing the same thing as before. I'm not measuring any temperature though. I'm just doing the same thing again with water. I still drank 1.5 cup of water just to keep it consistent with the milk setup. I wanted to drink the same amount. And I also waited between 1 to 2 hours after drinking water. Now, this should have no effect, but I still wanted to be consistent with milk all throughout. And what I did is I basically did 5 trials. So instead of 5 different temperatures, I just did 5 trials of the same temperature, which just so happened to be 68 degrees Fahrenheit. It was straight from tap, practically. So this is my data for water. This was all taken at 68 degrees Fahrenheit, and you can see it is pretty much the same on the data board all throughout. And so there is a warning incoming. There is a bar graph incoming. I don't really like this bar graph myself, but this is the only graph I can show, so I am very sorry. But here is a bar graph of that data. And so you can pretty much see that all throughout, you're hitting the same high notes and low notes frequently. And so now we have to basically compare the milk to water. And so what I did is that right here at, let's say, 52 degrees Fahrenheit, that was the average temperature of all of the milk trials that I intook in the first part of the experiment. So the 52 degrees Fahrenheit was the average of all of that. And now with water, I didn't really have to do an average on that in terms of temperature, because it was all at 68 degrees Fahrenheit. However, I did take the average value of hertz for both milk and water, and you can kind of see that on the graph here. With water, you're getting a higher vocal range, when with milk, you're getting a shorter one. And you can also go higher with water than milk. And so that's what the next conclusion says. I do felt like I've had a stronger singing voice after drinking the water than compared to milk. Now, since I've been told this, and a lot of people go through the same thing as I do, obviously this was expected. But with water, your voice goes higher and has a bigger vocal range than compared to milk. So the next claim that I'm making that I found out during this experiment is that with water, you can achieve a higher and stronger singing voice. Well, with milk, your voice can go weak and low. Now, hold on a second here. We showed that milk can deteriorate your singing voice, while water can help it. And then we showed that when you increase the temperature of milk, your vocal range decreases. So something feels missing here, and I can't really put my finger on it, so... Oh yeah, let's ask our good friend, the Wisdom Cats. What do you say, Wisdom Cat? You should vary the temperature of water. Oh yeah, that's what I'm missing. I need to vary the temperature of water. I did it for milk, so I should do the same for water. So how does the temperature of water affect your singing voice? Now, this is something that I personally do not know. So to answer this question, I'm doing the same exact thing that I did for varying the temperature of milk, but with water instead. So that same exact process that I did in the first experiment with milk, I'm repeating that again, except I'm changing the liquid from milk to water. So I did 1/2 cup of water, I varied the temperature, and a sink faucet is really good at varying the temperature, so I didn't really have to do much than mess with the knobs a little bit. I sing like my physics grade depends on it, and I measure how high and low my voice can go. And I also did wait 1.5 to 2 hours in between so that everything would be out of my system. Again, no effect, but I still did it just to keep consistent. So here's the data that I have. So for the temperatures of water, I got like 34 degrees, 46 degrees, 57 degrees, 70 degrees. And then even though I varied the temperature of water a lot, you're seeing that the range in your highest and lowest notes, those are really staying the same. And so now I did make the graph for water as well, and you can see that on the right here, but I also just copied and pasted the same graph that I had in the first experiment with milk, just so that we can kind of compare here. So you're seeing with milk, as we've stated before, is that as temperature increases, your vocal range is slightly decreasing from a bigger range to a lower range. And you can see that the highest note is decreasing and the lowest note is increasing practically. And so that's resulting in, as temperature increasing, your vocal range decreasing. Now with water, we can't say the same thing. See, as temperature is increasing in the water, your vocal range is practically staying the same. And so that's our third conclusion that we can reach. So comparing the graphs side by side, you can see a difference. As temperature of milk increases, the vocal range decreases. However, as the temperature of water increases, the vocal range stays the same. So also my voice also didn't feel like it changed that much varying on the water temperatures. However, I would highly not recommend drinking 86 degrees Fahrenheit water. It is practically really disgusting. So the third claim that I've drawn out from this entire experiment is that the temperature of water does not affect your singing voice. So what did we learn here today? So we learned that milk can deteriorate your voice, and while water can help it. So that is true, that what I've been told is that you should really not drink milk products, but you should definitely drink water products. However, with milk, if you do happen to drink milk, you would definitely want to drink a colder type of milk than a warmer one, because as the temperature of milk increases, your vocal range, that decreases. And another thing is that with water, which is what you should definitely drink, it doesn't matter how hot or how cold the water is, you can just drink the water and it will have no effect on your singing voice. And all of that can be extremely helpful the next time I step out on the stage and I start singing. So, I am now finished. Thank you guys very much.